Now we're going to tackle using a two-sample proportion test in Microsoft Excel. For this example, I am going to be using the two-sample tests Z and P Excel spreadsheet that I created for class. If you're enrolled in the class, you can simply download it from Blackboard. Otherwise, you can find a link to this very same spreadsheet in the description for this video. We're going to get started with a different example using movie theaters. This time, we're going to ask the question, is the book better than the movie? A recent top-grossing movie was based on a best-selling book. 500 movie patrons were surveyed upon leaving the theater. They were asked, A, whether they had read the book before seeing the movie, and B, whether they would give the movie version a rating of fresh or rotten. 196 patrons had read the book, and of them, 116 rated the movie fresh. 308 patrons did not read the book, and of them, 206 rated the movie fresh. With a little math, we can determine that the proportion for the patrons who read the book was 0.59, and the proportion for patrons who did not read the book is 0.68. The null hypothesis for a two-sample proportion test is always going to be P1 equals P2, or the proportions are both drawn from populations that have equal proportions. Ideally, whenever we do a proportion test, we want to be able to model against a normal curve. And most of the time, that is possible, and especially so when we have a large enough sample size or proportions that are close enough. Therefore, we need to check the assumptions for a proportion test before we actually use the test. If the assumptions are met, then we can model using a normal curve, and we don't have to introduce a correction factor to the formula that we use. Let's check the assumptions for this model. The proportions are 0.59 and 0.68, and the respective sample sizes are 196 and 304. The first assumption is that N1, or the first sample size, times P1 is greater than or equal to 5. Well, 196 times 0.59 is 116. That is greater than 5. Our second assumption is that the N1 times 1 minus P1 is greater than or equal to 5. In this case, 196 times 1 minus 0.59 is 206, which is greater than 5. We're going to follow the same procedure for the sample size and proportion for group 2. N2 times P2 is 80, which is greater than 5, and N2 times 1 minus P2 is 98, which is also greater than 5. Therefore, because all of these numbers are greater than 5, the assumptions have been met. And this means that we can use the normal distribution for this two-sample proportion test. We're going to use the typical alpha of 0.05 two-tailed test. But let me also show you the options that we have if you wanted to do a one-tailed test. For the two-tailed hypothesis test, the null hypothesis is P1 equals P2, and the alternative is that P1 does not equal P2. If you were doing a one-tailed test on the lower tail, the less than side, I would write the alternative first, P1 less than P2, which would leave the greater than or equal to for the null hypothesis. Same logic with an upper-tailed one-tailed test or the greater than direction. I would write the alternative first, P1 greater than P2, and the null is less than or equal to. Remember that, regardless, the null hypothesis always gets the equal sign. Equal sign always goes with the null. And now we're going to walk through those 5 steps of hypothesis testing. Step number 1 is to identify the appropriate statistic. For this setup, we are going to use the two-sample proportion test, which comes as no surprise because that's the test we're learning about right now. However, in the future, you may be given a data set in which you need to figure out what type of test to use based upon the data that you have. So it's important that you understand the setup for the data and choosing that test. Now, step number 2 is to state the null and alternative hypothesis. We are going to be using the two-tailed test. Therefore, the null hypothesis, P1 equals P2, or P1 minus P2 equals 0. And the alternative, P1 does not equal P2, or P1 minus P2 does not equal 0. For the level of significance, we're going to stick with our traditional two-tailed test at an alpha level of 0.05. And because the assumptions have been met and we are able to model using a normal curve, the critical value for the normal curve at alpha of 0.05 with a two-tailed test is 1.96. If we were doing a one-tailed test, that value would be 1.645. And now we're ready to calculate the statistics, and for that, we're going to turn to that Excel spreadsheet. We are using the two-sample tests, Z and P Excel spreadsheet, and we are on the tab for two-sample proportion test. If you want to see how this is all going to work out, click on the second tab, and you'll see the answers there. But we're going to go back to this tab, and we are going to enter some data. Well, where are we going to find that data? Good news, it is included for you on the final tab, which says Data. Let's go there. We're going to click on that Data tab, and here we have the data for those who have read the book and who did not read the book. All of the answers are in the form of fresh versus rotten. We can use text-based answers for this type of test, but we need to know what is our response of interest. So we can look at our settings over here. We're using the alpha of 0.05. The hypothesized difference is 0. There's no difference between the two groups or the two proportions. And the response of interest is going to be fresh. So we're going to have to enter that value here in just a moment. All right, first of all, let's grab these two columns and we will copy. And now we're going to jump back to our two-sample proportion test. I'm going to put the cursor in B1 and I am going to paste. And there is the data. Now, I mentioned that response of interest. We're going to enter that over here. So here's my response of interest. For those who read the book, it is fresh. I need to enter that twice now because in order for Excel to know what to look for, we have to enter it twice. There we go, fresh. Good. Now we have the sample size is based on how many rows there are in each of these two columns. The count is how many times fresh occurred in each of these columns. And the sample proportion is the division of those two numbers. We also have assumptions checks built in right here. We've done those by hand previously, but you can see that in both cases, the assumptions checks have been passed. By default, we're using a 0.05, but you can change that to a 0.01. You'll see changes occur over here, but we're going to go back to 0.05. And it is a two-tailed test, hypothesized difference of 0. Let's take a look at our criteria. We see that we're looking for a z-value of 1.96. It could be either positive or negative. And down here in our test result, our z statistic is a negative 1.956. So 1.956, wow, that is just short of 1.96. It's not quite there. As we look at the p-value for the two-tailed test, it is a 0.0505, almost over the line. Now this raises a really interesting question. We have a probability that is almost 0.05, just slightly larger than 0.05 instead of less than. We have a z-value that's really, really close to the critical value. How do we interpret that? Now, I have a video that explains the difference in interpretations that have been used in the history of statistics. How do we interpret that value that's just slightly, very close to the cutoff, but not quite there yet? So for this case, we're just going to use our traditional type of analysis, and so we're going to interpret whether it is less than or equal to 0.05 or not. So in this case, the two-tailed probability is greater than 0.05, and our test statistic does not cross the critical value, so we will say that this test is non-significant. And now we can finish writing up the 5 steps of hypothesis testing. Step number 4 is to calculate the statistics. So we came up with a value of a negative 1.96, a probability of 0.051. And the decision we made was that these proportions do not differ statistically significantly. But in that other video that I mentioned, I'm going to explain how interpretations have been done, either very strictly, and that's done for a very good reason, or just using that probability as the level of evidence against the null hypothesis. So you're going to see both of those in that video. Here's how I would write up these results in APA style, talking about the two-sample proportion test, why it was used, describing the research design, and concluding with the z-value and p-value that suggests that there is not sufficient evidence to conclude that book readers have higher expectations for the movie. If you are enrolled in the class, here's an example from our textbook that I'd like you to try. A tax preparation firm is interested in comparing the quality of work at 2 of its regional offices. By randomly selecting samples of tax returns prepared at each office and verifying the sample return's accuracy, the firm estimates the proportion of erroneous returns prepared at each office. Independent random samples from the 2 offices provide the following information. We have the sample size, and we have the number of returns with errors for office number 1 and office number 2. Let me show you a way that you can do this proportion test using Microsoft Excel and the spreadsheet that I created for you, even if you don't have data. Here we are back on the tab for the two-sample proportion test. I want you to scroll down a little bit, and you are going to find the two-sample proportion test without data. And again, I'm going to make up some values here just so you can see how this is used. For the sample size, about 34 and, 56. There we go. The count of response, let's say there were, 5 in that group, and there were 10 in that group. All right, gives me 2 proportions. My alpha is 0.05. I can change that if I need to. I can change the hypothesis value if I need to. Here's my critical value of 1.96, and the t-statistic is a negative 0.38, which is not greater than 1.9, so it is non-significant. And obviously, these are numbers that I simply made up on the fly. These are not the real numbers that you need for the example that you'll be doing in class. And let me wrap up with the correct answers. So you should do this example on your own, see what answers you get, and then you can check them to make sure they're correct. What is the 90% confidence interval for the difference in the proportion? The answer is 0.005 to 0.095. And remember, this is the 90% confidence interval, meaning you would change your 0.05 to a 0.10 to get a 90% confidence interval. The pooled estimator for P, again, kept at that 90% level, is a 0.1127. The standard error is 0.0271. The test statistic is a 1.85. So can we conclude, using a 0.10 level of significance, that the error proportions differ between the 2 offices? Yes, we can. And that is how you do a two-sample proportion test, either with or without data, using Microsoft Excel.